Hi, in this video we'll be talking about set operations. There are several set operations we can use: difference, union, intersection, and some more. They are pretty much like the operations on sets in mathematics. The method difference returns a new set with the difference of the sets involved. The difference of two sets includes all the elements that belong to one set and not to the other, or, more simply, all the elements of the two sets minus those which belong to both. So let's define two sets: days and weekend. Now the difference of the two sets contains all the elements of days which are not found in weekend. We can use it like so. Weekdays equals the difference days difference weekend. So weekdays contains Tuesday, Friday, Monday, Thursday, Wednesday. So all the elements of days which are not in weekend. So not Saturday and Sunday. There is an even shorter syntax to find the difference of two sets. We can just use the minus operator. So days minus weekend equals, and this is our weekdays as defined before. We can find the difference of more than two sets. So let's define three sets, for example, numbers, odd numbers, and prime numbers. And now let's find all the even composite numbers. So even, which means not odd, composite, which means not prime. So we can use the difference like so. Even composite numbers equals numbers difference odd numbers. So all the numbers which are in numbers but not in odd numbers, which gives us 2, 4, 6, and 8. And then we find the difference of days and prime numbers. So all numbers which are in this set but not in prime numbers. And now the difference is even composite numbers 8, 4, and 6. It even looks simpler if we use the minus operator. So numbers minus odd numbers minus prime numbers. A similar method is difference update. It works like difference, plus it removes all the elements of another set from the set it's called on. So let's define two sets, elements and nonmetals. And now let's use the difference update method like so. Elements, difference update nonmetals. Now our element set looks like this: copper, lead, iron. So here these two elements have been removed. And here we have a shortcut as well. Instead of using the method difference update, we can use the minus operator. So let's define our two sets again, elements and nonmetals. And now we can use the minus operator like so. Elements equals elements minus nonmetals. Elements, and here's the result. Or even shorter, the minus equals operator. So let's define these two sets again. And now we can use it like so. Elements minus equals nonmetals. Elements, fine. Another method is symmetric difference. It returns a new set with the elements in either of the two sets but not in both. So for this purpose, to demonstrate it, just let's define two other sets, prime numbers and numbers above 10. And here's how we can use the symmetric difference method. So here we get all the elements which are in one set but not the other. So here, for example, 3 is maintained because it's in one set but not the other, but 11 is not because it's in both. The shortcut for this method is the caret sign. So we could rewrite it like so. Prime numbers, symmetric difference, numbers above 10. And we get the same result. Then we have the method union. It's used to return a union of two sets as a new set. The union contains all elements that are in either set. So again, let's define two sets: big mammals and African mammals. And now we can use the union method like so. Mammals equals big mammals union African mammals. So this is what we get: mammals, all the elements that are in either of the two sets. A shortcut for this method also exists. It's the pipe operator, like so. So we could rewrite it like so. Big mammals, the pipe operator, which means union, African mammals. And we get the same result. Another method is intersection. It returns the intersection of the two sets as a new set. The intersection contains all elements that belong to both of the sets. So let's define two sets again: odd numbers and prime numbers. And now we can use the intersection method like so. Odd prime numbers equals odd numbers intersection prime numbers. And the result is odd prime numbers 3, 5, 7, 11, and 13. So all the prime numbers except 2. So all the elements which are contained in both prime numbers and odd numbers. This method has a shortcut as well. It's the ampersand operator. So this sign. And we could rewrite it like so. Odd numbers, ampersand, prime numbers. Okay, that's it for this video. If you like it, a thumbs up would be great. Also, make sure to subscribe for future videos. If you want to leave a comment or ask a question, you're welcome to do so. Thanks for watching.